Hello students, welcome to this session. In this session I will be discussing about the second chapter of your operating system, which is process management. So process management, we have already discussed like what is program and what is process. A program is any set of instructions will consider as a program, and once that program is loaded onto your memory and it starts executing, it will convert into process. Okay, so just understand, if you have written, or if you have any program, any software or any program, so it is like your program which will contain instructions. Okay, it will contain instructions, or will consider as set of instructions will consider as a program. Now when this program will convert into process, okay, when this program will be converted into process, in the sense, once this program is loaded into RAM or into memory and it is executed by CPU. So once this happens, it is considered as a process. A process is nothing but any program under execution will consider it as a process. Now when I say execute, execution is done by CPU, that is your processor. So processor is responsible for executing the instruction. Now when to execute this process and when to give input or when to take output from the process, everything will be taken care by your operating system. Operating system will be responsible for a function called as scheduling. So what is scheduling is? Scheduling is nothing but the operating system is going to select any process for execution. So when this happens, so when, if I say I have three different programs, say I have MS Word as a program, and I have Excel as a program, and I have my processor. Okay, so you should remember one thing is, processor can execute only one process at a time. Okay, so one process at a given time it can execute. Okay, only one process at a given time. It cannot execute two programs or two processes at a time. So if you have Word as process 1 and Excel as process 2, you have two processes in your memory. And if you want to execute Word, your operating system is going to select Word and it allocates CPU to this Word. So this process is considered as scheduling. Scheduling is nothing but the operating is going to select which process to execute. When it is going to select the process, it also allocates processor to it. So saying that this process will be loaded with MS Word, so that it will start executing MS Word, which is process 1. So if I want to select Excel, or Excel if I want to execute process 2, then operating system is going to allocate processor to Excel. So once this done, then this will stop executing and it is going to execute Excel. So this type of processing will consider as I told you, which is scheduling as well as switching. Switching is nothing but it is going to select one process, and from one process it is going to switch to the other process. So it is going to change to the other process. These two things will be taken care of your operating system. So just understand, a program is nothing but any set of instructions will consider as a program. Once that particular program is loaded onto the RAM or onto your memory, your operating system will allocate CPU, that is your processor, to that process. So then it will be under execution. So then it is called as a process. So any program, whenever it is loaded into RAM, it will be staying in the RAM. Okay, so once the operating system allocates CPU to it, it will convert it into process. Okay, now next we will see what are the components of a process. So components of process. So what are the components of process? What a process include? A process includes things like instructions, or we'll consider it as object code. So we have discussed about this also. So when you write any C program, this C program will be in high level language. Okay, which will be in high level language. Now, once you compile that program, after compiling that program, it is going to generate a file which will be having object code. So this object code is which type of language? It is machine level language. Okay. Now, whenever you want to execute, this object code will be loaded into the memory, not the source program. Source program will not be loaded onto the memory. Only the object program will be loaded onto the memory. So, what does a process contains? Process contains object code. What is this object code? Object code is a machine level language which will have a set of instructions. And next thing, it will contain data. Okay. Say for example, if you are doing addition of two numbers, I need the value of A and I need the value of B. Two input values I need. So those values will be considered as data. So for any process to execute, it has its own set of data which will be your component. And third component you are going to have is, say for example, status. And fourth component will consider it as resource. Okay. So what is status is? It is going to represent, say, once a process is created, we'll have several states of that process. Whether the process is executing, whether the process is waiting, and whether the process is doing some other function. That details will be stored into status. And again, resources. Resources is, I have discussed in your computer, or whenever you have your computer, we have several components in that: input devices, output device, and memory device. We have several components there. So those hardware devices or any files that you store in the memory, so those things will be considered as a resource. Say for example, I am using some, if I take a process. So if I take example for process, and what are the things that you are going to have in a process. So simply consider I am creating any program, or I have a VLC player. Okay. So VLC player is a software or a program. So its object code of the VLC player is nothing but it will be loaded onto your memory, which will create a process. In the sense, in your computer, if you have installed VLC player, once I double click on that particular VLC player icon, it is going to load the object code or the object code of that VLC player into the RAM. So then the process is created. That is first the object code. Second, data. What is data? Data is nothing but, say for example, if you want to play a song, I'm going to play a song, some song called as song1.mp3. This will be the data that will be used by this object code. This object code is going to use a file called as s1.mp3. And resources. It needs resources like speaker, and it needs resources like hard disk. Why hard disk? Because this mp3 file will be stored into some hard disk. So this, from this hard disk, it is going to access the data, and it is going to give the output in the form of a sound which will be displayed on the, or will be sent to speakers. Those will be resources. And status. Status is whether the VLC player currently is under execution, or whether it is in the stop state, or what state it is, that will be displayed in the form of status. So these are the components of process. So a process will contain these components: object code, what is the data that is required, and what is the status, and what are the resources that particular process needs. Okay, so hope this is clear, and we'll go to the next topic. Now we'll see what are the difference between object, process, and as well as program. When you say program, program is set of instructions. Okay. Next, what is process? Process is if these set of instructions are under execution. If these set of instructions are under execution, then it is called as process. So program is set of instructions, process is program under execution or set of instructions under execution. You can write the both of the things. And program, where it will be stored in your hard disk, or you can also write secondary storage devices. So it will be stored in secondary storage device. Where this will be stored, it will be stored in RAM, or you can also write main memory. In main memory we are going to store process. Okay. Here the object or the program will be in passive state. Okay. Here it will be in active state. So what does that mean is, any program that is stored in the hard disk, it will stay there until it will be loaded onto your say CPU. So once it loaded onto your CPU, it will go to active state so that it will be executing. And here it will be static object. And here it will be dynamic object. Okay, so the information whatever you are stored in the form of a program, the data will be in the form of static object. That is, the values whatever you want to store will not change. Whenever you consider dynamic, the data or information whatever you are going to store in that process, it is going to change. That is why it is called as dynamic. So anything that is changing will consider as dynamic. Whether it is anything that is fixed will consider as static. So when you consider this program as well as process, these are the differences that you will come across. What is a program and what is a process? Okay, it is just like when you write a C program, it will be a program. Okay, so if you write any C program .c, that will be a program. Once it is compiled, it is going to generate the object code. Okay, so this object code, you start executing. So once this will be loaded into your or stored into your hard disk, this will not change. That is why it is static, and it is also called as passive. So whatever information that you save, once you save onto this program 1.c, the content will be stored into a hard disk, and it will have a static program instructions, and it will not change. That is why it is passive. And when I say object code, this will be loaded onto RAM or primary memory for execution, and this will be dynamic. Dynamic in the sense, if I write a program A equal to 5 and B equal to 5, and here if I store A equal to 5 and B equal to 5, that value will not change when it is a program. When you consider an object, when you consider it as a process, if you have written any instructions, the value of A and B can change. That is why it is like dynamic. And again, past active. So since the whatever data that you are going to have in that particular object code, it is going to change, it is considered as active state. Okay, so these are the difference between what is passive or what is a program as well as what is process. So I'm next coming for the process states. Process states. So what are the different types of process states you have is, like it is new, ready, running, waiting, as well as terminate. Okay, so these are the states of a process. So once a process is created, or once you start any process, it can be in any one of this state. So what are these states? We'll see one by one. Say first we'll consider new. Okay, what is new state is, once a process is created. Once a process is created, it will be in the new state. In the sense, the process will be loaded onto your main memory. So once it is loaded onto main memory, it with its components like what we have discussed, object code, data, resources required, and status, everything will be loaded, and that will be loaded onto the main memory. So then it will be in the state of new. So the state of the process is new when it is created. Next, it will go to a ready state. Okay, so I'll just write again here. We have first new and then it will go to ready state. Okay, so once the process is created, so memory will be allocated for the process, so which is like your process creation. So that state will be considered as new state. So after it is created, next it will go to ready state. Ready state, it will be in memory, we'll consider it as memory pool. Okay, so memory pool is nothing but where it will be in the queue. So it will be in the queue. We have discussed in data structure like stack, queue and other things. Similarly, the process whenever it is created, it will be going into some memory space. So from that memory space, the CPU is going to select for execution. So once it enters to that particular state, it will be in ready state. So it will be ready for execution. Whenever a process is ready for execution, it will be loaded onto some memory space where it will be in the ready state. After it is in ready state, next we'll go for running state. So what is running status? If the CPU is executing your process. If the CPU is executing your process, then it will be in running state. So from new state, we'll go to ready state. From ready state, we'll go to running state when a program is under or when the process is under execution. From execution, it will go to waiting state. Okay. So when it goes to waiting status, so for example, if I have written a program, it starts executing. In between, it needs some input, say enter the value of A, enter the value of B. In that case, the process from CPU, it will shift to waiting state. Why? Because until you give the value of A and value of B, the process will be idle. So instead of that, what we are going to do? We are going to send that particular process to waiting state. Once the input is given, once the value of A and value of A is given, then from the waiting state, it will again come back to ready state. And then again, it is going to be executed by your CPU. So when there is any IO function or if there is any switching process or any interrupt happens, in that case, from running state, it will come to waiting state. Once the IO operation or whatever function that is there, if it is completed, again from a waiting state, it will go to the ready state. Okay. So after that, at last, we have the end state or the dead state. We'll consider it as end, dead or terminate state. So once the process or program is completely executed, it will go to end state. So the process states will be new. So when a process is created, it will enter into new state. When the memory is allocated or the process is loaded onto the memory, it will go to ready state. So once the process starts executing, it will be in running state. If there is any things like input output requirement or any resource requirement or any functions like that, it will go to waiting state. After completion of that particular event, it will come back to a ready state. So and then it will be executed by the CPU. Once all the instructions are executed in the object code, then it will go to end state or terminated state. So this is about what is process states or different states of your process. So just remember this topic we are going to discuss in Unix also, the same method. So just understand this concept. It is easy to understand. We have these states like new, ready, running, waiting as well as terminated. Once a process is created, it will go to new state. Once it starts executing or once its memory is allocated, it will enter into ready state. From ready state, it will go to running state. And if there is any interruption or events that has to occur, it will go to waiting state. Once that is completed, it will come back to ready state. After completion of the execution of all the instructions, it will go to end state or dead state. So this is about your process states. So in the next session, I am going to discuss about the next topic, which is PCB, called as process control block. Okay, thank you.